Good morning and welcome to a Micrographics webinar. Today's webinar is going to be on Fusion 360's nesting extension, the nesting and fabrication extension. I did a webinar about 6 months to a year ago when just before the extension was released and it was still in the preview phase. This is going to be an update on that extension, on that webinar. So there will be some overlap, but there will be some new information in this webinar. So welcome. The session will be recorded. Participants are muted, but you can take advantage of the chat panel to ask any questions, and I'll answer these either as I see them or at the end during the Q&A session. My name is Carl van Rooyen. I'm an application engineer with Micrographics, and this presentation will be put up onto our Micrographics YouTube channel. So if there's anything you'd like to recover or pick up any information again after the fact, it will be up on our YouTube channel. So on today's agenda, we'll be having a look, a short intro to explain what the term nesting refers to and why a company would want to use it. We'll then have a look at the extra features the nesting and fabrication extension will give you once you've unlocked that extension. And then this will include in-depth slides on the following sections: the advanced arrange tool, the nesting preparation controls. Those would both be in the design environment. And then once you go into your manufacture workspace, how would you set up your process materials library, how to create a nesting study, reviewing the results of that study. And we'll look at exporting the results, having a look at the possible nesting outputs. We'll then close off with a summary and Q&A session. So what is nesting? Now, nesting is not what we see there on the right-hand side. We're not talking about those types of nests. What we're talking about is the nesting of flat components onto a sheet. So what is nesting? Well, nesting is a process that typically happens between the design and manufacturing steps. So you would have your design, you would need to create the nests, and then that would go and be manufactured. And so basically there's a step in planning how the parts will be manufactured. Usually with a person or department dedicated to this task. And the task basically entails placing parts down on a sheet of material for cutting. If these parts are bent parts, so they're not flat, then the unfolded model or the flat pattern is used. So we'll take a bent component, flatten that out, and then arrange those flattened components. So as I said, these flattened components are arranged. They're organized on the sheet, basically like a jigsaw puzzle, to fit as many of them onto the sheet material as possible. And this in turn is optimizing the use of that sheet stock to reduce the amount of wasted material between the components. So there are certain criteria for organizing the parts, such as possible grain direction. If you're looking at nesting wood or any material that has a veneer with a grain on it, even if you're looking at brushed stainless or brushed aluminium components, and there may be the sheet that you have is pre-brushed in a specific direction. And there may also be things like single-faced materials where a certain side of the material has a brushed finish. Once again, might only be brushed on one side, or there's a texture on one side that is not on the other. And so these considerations will be discussed later when we look at the nesting studies. But that is basically your intro into what is nesting and Our next slide here, we will look at why is it important to nest, or why is it important to have something like the nesting and fabrication extension. Typically, without having some sort of nesting program, you would be nesting manually. So you'd be taking those shapes, manually trying to organize and position them on a flat sheet. So being able to automate this task and have the computer do this is going to be more efficient than manual nesting. And at the end of the day, that will reduce the time to create that nesting study. This time saved can be then spent by the designer doing more tasks that are going to be value-added tasks. It opens up their time to do more value-added tasks. At the same time, it's going to allow you to reduce the wastage of material. Automatically calculating and getting the best optimization on that sheet of material is going to help reduce the wastage. And essentially, at the end of the day, if we're reducing the wastage on those sheets, we can reduce overall component cost. And after the study is done, that can also be used to generate reports on material usage and essentially material wastage. You can see how many sheets of a specific material are required to complete a job. That can be used for ordering to make sure that there's enough stock. It can be used on quoting to make sure that you're quoting the correct amount on the stock. You can even start using the material usage to optimize your quotes and get a better quote out. They can also then end up being used to calculate or help calculate down the material cost per component. And see how many components have you nested, what's the overall cost, work out the cost per component. And as I mentioned, once again, calculating the overall material costs. So the nesting will allow us to generate a whole lot of information about the material used. And we'll see that close to the end of the presentation with our report generation and what we can pull from those reports. So just having a look here into what are the typical parts that would be created from the nesting. This is basically an easy question to answer, and I've already alluded to this. Any part that is made from flat stock or sheets can be nested with other parts of the same material spec. So basically this would mean that as long as the material type is the same and the thickness match, those components would all be put onto the same sheet. And if there are multiple material types or thicknesses in your design, those would then be split out across the relevant material specs for each component. Many components can be made from flat stock, be it steel components, plastic, cardboard, even leather. Here we have a few examples of display stands made from plastic and cardboard, as well as some metal components which could be part of a much larger machine. All of these items would have started out as flat stock and then being cut and bent into their final shapes. In one of the most extreme cases, we can look at shipbuilding. All these sections of the ship would have been nested into steel plates and cut out before being assembled and welded together. So kind of looking at the two extremes, there's some small shop fitting and then some larger sort of shipbuilding components. So I'm going to pause here quickly and go into the software and actually give you a live demo and a quick view of what the final result would look like. This will give you a better understanding of the different sections we'll be looking at next. So we go into the software and I have a pre-created box over here, and in this box I've just colored the different materials, different thicknesses, just to make this, or the different thickness materials to different colors just to help identify what's going on here. And if I take this to the manufacture environment, you can see the different nest groups. Each of these groups represents a different material or material thickness. And then within each group, we have our actual nested components. So here is a sheet with a set of components nested on it. If I activate the next sheet, we'll see that only a portion of the sheet is used, and we have those components nested, so the remainder of the components nested on the second sheet. We go over to the next portion of the nest study. We've got two sheets there. We've got this sheet with most of the parts on, and then the second sheet with the remainder of the components on there. And then the last one here, a couple of components that fill up that nested sheet. So there we can see from basically just a predefined or pre-made design here from that existing box. Okay, that is unfortunate. Apologies for that. My Fusion has just decided to crash. Let me get that open again. So while that opens in the background, I will just continue on with the rest of the slides. We had a look there basically at the completed assembly and then the nests created from that. And we'll go through how this process is, we'll go through this process and how the nest is created. But first what we'll do is we'll talk about the nesting and fabrication extension itself and what do you get with this extension. So when you purchase Fusion 360, you will get the basic Fusion 360 package. And if you need to expand your functionality, if you work a lot with Fusion 360 and you work a lot with sheet metal or flat components that can be cut from flat sheets, then having the nesting and fabrication extension would definitely be a great assistance to that, help streamline the workflow. But what do you get out of the nesting and fabrication extension? If we look, I've highlighted a few of the things here. In the design workspace, you would get the advanced arrange tool. This allows you to basically arrange items on a flat surface. We'll get nesting preparation controls, which allow you to prepare your design for nesting. Process material libraries allows you to create your materials. We can then create our nesting studies, review the results, and then we'll have a look at the nest exports and outputs. What can we actually gain from creating those nest studies? So we'll have slides on each of these sections, and we'll go in depth into each of these. Okay, so looking at the advanced arrange tool, this would be in the design workspace. It allows you to basically quickly arrange parts from your assembly and preview essentially what your nest would look like for, let's say, a single component. So I kind of look at this as a very quick way to just preview how a single assembly would flatten out onto a sheet. So you can quickly arrange those components onto a flat sheet. Essentially doing this in the design environment, that advanced arrange becomes a feature in the history of the component itself, in the design history. There's a lot less setup than in the actual nesting process, but you can only do essentially one component at a time. You can't say, well, I want to produce 10 of these. If your assembly is made up of 6 parts, as mine is showing up on the screen, it's going to just flatten those 6 parts. What you are able to do is you're able to set your stock size, whether you use an existing sketch or you select a work plane and set the dimensions. And then you can set your arrange settings, pretty much how far apart should the components be spaced, and a couple other settings there on that arrange that we can look at during a demo that I will do. So the advanced arrange option, like I said, in the design workspace, typically if you're wanting to quickly, let's say, machine or cut out just a single set of components, and it will arrange it onto a sheet of a specific size. Then if you want to take an assembly and you want to create a nesting study from that, we can use you can use the nest preparation controls to predefine specific information within the design environment or design workspace before we get into actual nesting. So here on the right hand side, I've got a wooden box with 6 parts. And what the nesting preparation controls allow you to do is it allows you to select components that you want to either include or exclude from the nesting study itself. So we can see here on the far right hand side of the slide, we've got options to ignore specific components. So you'll see there's an ignore automatic selected entities, and the lid there has a warning next to it. So that lid there has actually been ignored. So that won't be included in the nest study if I create the nest study selection. The idea here is that for components that are, let's say, not sheet metal components, you can choose to include them in a study. If you're doing, let's say, woodworking, you have a nesting router, you want to cut those components out of the board of, let's say, MDF or chipboard. You could choose it will include these. And at this point, you can also specify the grain direction. Now, typically the grain direction would be down the length of the part, so the longest measurement of the part. But this might not always be the case. Your design may require the grain direction to be across the width of the part. And so we'd be able to adjust the grain direction or the angle of the grain direction at this point as well. And this will affect how the component gets nested onto the sheet during the nesting process. So here we have our preparation controls. We can pre-process components before we start to create the actual nest studies. Yeah, so we're going to go back into a demo here. Let me just double check that my Fusion is opened up, and I'm just going to go ahead and open those recovery files so we can work from there. Another nice thing about Fusion, if you do have a crash, it has a 5-minute, if I remember correctly, a 5-minute autosave where it saves your recovery files. So I'm just going to open up those files and then continue on with the demo. So you can see my wooden box here in the background while we just wait for the control box to open up. So just to demo those 2 options, basically if we go here to the modify drop-down in the solid tab, we've got this arrange option here where we can use to arrange the object. So selecting that arrange command, we can select the objects to arrange. So I'll go ahead here and choose the outside surface of each object. And you'll see as I select the object, we get the option for the grain direction to adjust or set the grain direction. I'm going to go and grab all 6 of those objects. They are then listed down on the right-hand side, and we can choose or limit the rotation or the arrangement as it's arranging these items. So I'm going to say, well, let's only allow 180-degree rotation because of the grain. We don't want the grain to be misaligned. And then if I go over to envelopes, this is where we'd be able to set the envelope or the size of the sheet that we'd be arranging on. So from here, I'm going to select plane, grab a work plane. Let's just go ahead here and grab origin work plane. And then on that work plane, we'll set a envelope. So let's say a piece of wood, solid wood that is 1.5 meters by 150 millimeters wide. That will generate that envelope that will arrange those components. Now, if I just have a look back at my objects, I'm going to flip this to be face down, so that selected face, the face that I selected, is put down onto the envelope, and that basically opens up all the machine sides facing upwards on this piece, on this. So we have our envelope options. We can set grain direction for that specific envelope that we specified. We can see here that arrow is the grain direction. It is aligning with my components. If we change that, the components should flip around to align their grain direction with that. And we'll see that only 2 of the components have been arranged. The other 4 don't fit in the width of this piece. So at this point, I might go and decide, well, you know, I've got a smaller piece of wood. Maybe it's only 1 meter long, but it's 200 millimeters wide. And I'll have a look there. There we go. So I've got the pieces now fitting with the grain direction running correctly on that piece. So we can adjust pretty much all the things that you need to set up. And this is a quick way of, it's a quick way of nesting just a single design. It's okay not to spend too much time here, and that creates that arrangement of components to fit on that selected board. And we'll see it's created as a feature in the timeline, and we can go in and modify that as required. So that is the arrange option. If I just drag the timeline back one just to get rid of that arrange, we can then look also at utilities and go into the nest preparation. Under the nest preparation here, we can basically choose to ignore specific items. So if I wanted to ignore the selected entities, I can go in here and click the lid and say, well, I want to ignore the lid and only nest the rest. In this case here, I'm going to select not to ignore anything and make sure that everything here is included. Tells us the quantity as well, so we have 1 base, 1 lid, 2 fronts and 2 sides. We can also at this point go and choose component grain direction. So per component we can set the grain direction. If for some reason we want to have a different direction for the sides, maybe we want that grain to run vertically, we can adjust that grain direction. Click OK, and that will then modify or set up those components, set up those components for nesting. Let's get back to the presentation, and then we need to look at all our options to set up for nesting itself. So the first thing to make sure you have set up correctly is your material libraries, so your process material libraries. Now in the material library we've got materials and packaging. Essentially the material would be the actual type of material. Is it aluminium? Is it steel? Is it stainless? Is it MDF wood? You choose the material type. So you create your material, and then under the material you create what they term your packaging. And your packaging is basically how you purchase that material. Do you purchase it as sheets, or do you purchase it on a coil? And this allows you to then set the length and width parameters for that sheet or that coil. So depending on your process, how you are feeding your cutting machines, you would set your packaging according to that. And we also have a trim value that we can set, which basically allows a gap between the edge of your material and the sides. Typically, if you're looking at something like MDF or chipboard, boards aren't always perfectly square, and they are typically slightly oversized to the stated dimensions. So, and also the edges could potentially get damaged in transit. So trim value would be allowed to set the component slightly in from that existing edge to allow for the parts to be cut slightly inside of the material to avoid any damage or to avoid the part from going off the side of the material, especially if it's not aligned correctly on the machine when being cut. So your process library will allow you to set that up. We can see there just an example of coils. We are using coils. And part of the library here, just to show you how you would be seeing or viewing your library, we can see that we've got a table with the different materials listed. You can see the material identification, the material type, its thickness, what category does it fall under, density, and so on. So we have a couple of different tables with all the different properties that get listed. We can also create material presets. Now, material presets allow you to populate a document with all the materials. So you'll do this once. You create a document, a blank design. You populate your library with all the materials that you would use. And then what you do is you create your preset. In this case, I've shown a stock materials preset. And that preset stores all of your materials that you created. So at a later stage, when you create a new nest, new document, you can then load those preset materials into that document. So you're not having to create your materials from scratch every time. Then we move on to the nest study. The actual nest study itself, when you select the component sources, this will check those nesting pre-setups and it will then list the components that are available for nesting. That will also show you properties that are applied to each component. So you can see there in the table on the left-hand side. If we select a component from the left, it gives you information on the right as well as a thumbnail of the component on the right-hand side. This also gives you the opportunity to adjust any settings per component. So you would be able to unbind the settings and change, let's say, the rotation angles that are allowed and the deviation that is allowed from the rotation. So that would allow you to just preview what's going to be nested and modify any settings. After you've checked out your component sources and you are happy with the settings, you can then go to create the actual nest study itself. Now, the nest study itself has quite a few tabs associated with the study, but this is where you would basically set up your settings for your actual nest calculation. So on the study tab, we've got our general settings where we can add a comment for the study. That comment may include a job number so that we can assign the study to a job number. A job quantity as well. Single value basically would allow you to set a job quantity of, let's say, 4 in this example. So a single value of 4. So we have an assembly, we have source components brought in, and we are going to just create 4 of those assemblies. But we also have the option to choose multi-value. And so this is if you've brought in multiple sources. So you can see in the bottom there, I have a source assembly 2, which is the small control box, and the source assembly 1, which was a large control box. And so the order may be for 4 large control boxes, but only 1 small control box. But they share materials. So you can cut both of those in the same job. You can cut both of them in the same nesting study, even though they have separate quantities, which is quite a nice ability there. We can also set stack size. So if you're flame cutting or laser cutting through multiple sheets, you can set how many sheets you are stacking on the machine at once. Then the next tab is the shape tab. I'm not going to spend too much time on each of these tabs. We will see a demo on this. But basically you can preview the shapes that are included in the study. And at this point in time, you can also deselect shapes you do not want to have as part of the study. So in this case, if you did miss something in the sort of the pre-nesting or pre-processing for the nest, you'd be able to deselect. I've got two objects highlighted here on the right-hand side due to their thickness, 24 and 186. So those are not flat sheet metal components that need to be cut. So they're being excluded. The packaging tab basically allows you to choose from the list of available packages, what are you actually going to use to process. So that at the bottom shows you your available stock. Those are the sheet sizes that you have. You can then choose to include or exclude those from your calculation. And on the right-hand side, far right, we can set the inventory quantity. So if we know we have 10 sheets of the first line item, the 2mm steel, we're able to set, okay, we have an inventory quantity of 10 of those. Then maybe we have oversized sheets where we have 2 oversized sheets. And then you can set the quantity for those as well. So this will allow you to set in your inventory quantities, and it will calculate according to those inventory quantities as what is actually available to nest on. The global parameters are linked to the actual calculation. So where do you want to start positioning components on the sheet, and essentially what your desired yield is, and how long do you want to wait for the calculation to actually get to that desired yield, or if it doesn't get to the desired yield, how long should the calculation run for to try and improve the yield. And lastly, when the study is complete, what output information do you want? Do you want to create a manufacturing model, a 3D of the actual layouts? Do you want to show the part outlines in that? Do you also want to include the stock in the manufacturing model? So we'll go back to Fusion. We'll have a run through on how this is achieved. So I'm going to use the small box because it's a quick process. It's a couple of easy components. So we'll go through to the manufacturing environment, and we'll go over firstly to the sources. We'll go to component sources. That will list the components that are to be cut. And we can see here that we have, from the wood box, we have all the components listed from there with their material, some material 1/8mm, and we can see our settings here on the right-hand side. So if I pick the base, we've got the settings on the right-hand side. We can unbind and choose and deselect any options if we need to, change any options here as required. And so we can go through the sources. The sources will typically be, or the source parts will typically be for obviously the design that's open, but you can also click to add and select a second source. So I'm going to choose the small control box and select that as a second source of information. So we have the wood box, and then we'll add the control box here as well. And so here we have that small steel control box, and we have all the information linked to that box as well. So I'm actually going to go ahead and remove that, not to complicate the calculation and make a long calculation time. I'm going to remove that. Click OK, I'm happy with the sources. We'll then go to create the nest study. And for the job quantity, because I only have the single box, I'm just going to go single value, and I'm going to say I want to create 4 of these boxes. If I go multi-value, it will list the wooden box. I can say, okay, I want 4 of those. If I left the small control box in, that would be listed, and I could choose how many of those I want. I've got single value 4, stack size of 1. The shapes, I'm happy with all the shapes. They can be included. Here it tells me I have 4 shapes selected. It's going to be a total of 24 parts to be nested. So I'm creating 4 of them, 6 parts per object or per assembly. So 24 parts total to be nested. Packaging, this is only maple board, so I've got a board here that I want to use that has been brought up already into the study, and we can set an inventory quantity here if required. Global parameters, I will leave this as default, and outputs, I'll leave that as default. Clicking OK will then generate that study, and we will see that the result of the study comes out. I've left some spacing here between the components so that there's enough space for, let's say, a router to get in between each of the components and cut out these shapes that are required. So that would be your component sources, creating the nest study. What I didn't go here was look at the process materials. Go into that library here. We'll see that I have a material 1 setup, which is the board. That material, I can rename that to maple, and we have the material here all set up. The packaging, it is a board that is 1.5 meters by 150 millimeters width. It's rectangular. We could fill in a cost for the material for that board. And under nesting, we have our information for our nesting. How do we nest on this board? And I spoke about item separation. I've allowed 15 millimeters to allow for a cutter. Let's say it's a 10 millimeter cut or 12 millimeter cutter to get in between the components. There's a grain direction as well. 0 degrees would be along the length. That is how I want it. That's fine. And there you'll see the frame width 10 millimeters. That's allowing 10 millimeters between the parts and the actual edge of the board. I'll click OK because I've updated those settings. The nest study needs to be generated again. And we have our updated study according to the new settings. So there's our first board. And this is created as a manufacturing model. So we can take this and send it straight to a setup and create a CNC setup from that. I can activate the second board. There we see the second board. And so this is a nest study 3 that I've created. You'll see I have some other test studies here that were created earlier as well. So I've got a couple of nest studies that were generated. This is the current one, working with that one with the 2 boards. Okay, so let's have a look back at our presentation. How do we interpret and review the results from our nesting, from that nest study? So the results, our outputs that we get, we essentially get a nesting node that is created for each material type. So in the example on the right-hand side here, we see nest.46, nest.47, nest.48. The screenshot was taken before some of the automatic naming features were brought in. So they just incremented the number one at a time. But each nest there represents a different material type or thickness. And under each of those, we have a node created for each sheet that is required for the job. So we see there sheet 97, 98, and 99 would all be the same thickness with the components nested on those. And what you're allowed, or what you can do here, is you're able to actually grab those sheets and compare results across sheets, or even create reports across those sheets. So go ahead here to the next slide. We'll see the outputs. What can we actually do from that study? What outputs do we get from that study? So the outputs there, as I mentioned, from the study we can output a manufacturing model which allows you to create toolpaths directly inside of Fusion. So we could take that output, that manufacturing model as we see in the image on the right, and we can do some laser cutting, waterjet cutting toolpaths on that, or if we were doing woodworking, a router profiling to cut those shapes out. You can also export your sheets as DXF or MSR files to use in third-party nesting software. So if you're using something like, I can remember the brand now, okay, the name's left me, but if you're using a third-party nesting software that maybe was supplied with your machine, then you could export a DXF or MSR file depending on what it supports. So even though you create the study in Fusion, you don't have to do the machining in Fusion. It can be exported to then cut or create the CAM on another package. Fusion also has the ability to create labels. There are a couple of built-in templates for the labels. We can see a label here on the right-hand side with information from the nest study included and a picture of the profile on there. And finally, we can generate reports. We can generate reports on the amount of sheets used, the part costs, even the excluded parts, so we can see what was not cut in the nesting study. Maybe it didn't fit on the existing sheets that were available. So we'll go for our final demo before we go to our summary and Q&A. And I'm going to just, as a very quick example here, under the manufacturing models for this maple box, we grab those two sheets. We'll right-click on the sheets, and you'll see that we have a couple of options here for what we want to do with those sheets. So I can go and compare, and this will bring up a report that compares those two sheets to each other. We have down the left-hand side, we have our information with regards to that sheet. So how efficient are we on those two boards in this case? Things like the efficiency, the material ID, the date and time that this was created, packaging cost, total cost of the nest. You can see that information per nest. This can also be changed into a column view, basically a list, it's a grid view. And this is a lot easier to identify differences across the rows here as well. So we can see the remnant cost for each one, the actual sheet area, total nesting cost per board as well. So that would be the comparison. We can compare sheets, or we can compare across studies as well. So let me have a look at the study here quickly. Those studies are blank. So let me create a study. Let's see, this was edit nest. So on this nest we created sorry, let me go all the way to the top here, edit nest study. We looked at manufacturing 4 of them. Maybe we want to see if we create a new study and manufacture 8, we could do a comparison across studies. So let me go ahead here quickly. Let's do a new nest study. We're going to manufacture 8 of them. And we'll see in that new study, if we take those 2 studies, study 3 and study 4, we can compare studies. And so we'll see the information per study here, total cost of study, total nested cost. And we could work out there which would be better. Should we manufacture 4 or 8 to be more, like I say, efficient in the design. So you can compare the studies. We can also generate a report. So let me have a look here on this study. You right click on the study, you can select a report option, and that will load up a report. We've got a bunch of templates that we can choose from. I've got the default report template active here, and that will give us the source parts. So we can see what were the source parts, and it is controlled by grain. We can look at the inventory. We were pulling out from 1.5 by 150 millimeter boards. and the sheet details, so per sheet, what are we actually cutting. So part number 1 is the base. We've got 1, 2, 3, 4 bases. We've got 3 lids, and we managed to fit 2 sides onto this piece. And we can go down according to that specific sheet. What are the properties for that sheet? There you can see you can pull quite a lot of information from these reports. And we have different reports. We get a full report, default report, full report template. So we have those options for the different templates. And we can then print that template out if we are required to have that template printed and shown for production. So we can do reports. We can also then do labels so that we can label the components as they come off. Same as with the reports, it's generated in much the same process. You choose a template. There are a couple of desktop A4 printer sizes with template sizes on there, label sizes on there. And there is also a label printer option, basically a 2" by 1" label printer size, and we'll see that brings up that preview slightly differently. So you can choose a template size, print out those labels, and those labels can be stuck onto little parts as they are cut. Then finally, if you right-click on the actual sheets themselves, you've got the options to export those sheets. So if I choose export here, we can then export to a DXF or MSR file type. And then you choose the location on your C drive where you want that to be exported to, and you can use that in your third-party applications as mentioned. Alternatively, if you are not using a third-party application, you're working in Fusion, you can grab a nest study. Let me do this with the Nest Study 4. We've got 4 different manufacturing models here. We can grab Nest Study 4 and say create setups from manufacturing model. And what that will do is that will create 4 different setups, 1 setup for each board that was created. And so for each of these setups, we can then go in and create our programming. We can program our CNC toolpaths on that for cutting those components. That'll bring us to the end of the demo. I can go back here now to presentations, and we'll close off with the summary and Q&A. So basically, for a summary, very simple. Why nesting? Nesting is going to allow you to save time through the automation of the process. It can help you predict and optimize material usage. That can help you with getting more accurate quoting and being able to, let's say, predict and order stock for manufacturing as well. Also allow you to calculate individual part and overall material costs. And you can nest any components, whether you're working with sheet metal or even woodworking cabinetry, nested doors. And at the end of the day, it creates a manufacturing model which allows you to program your machining or cutting, and you can output reports, labels, and third-party files for passing on to other software if you're using other software for your actual CAM process, your machining or laser or autojet cutting. So a nice quick summary just to sum up what we've gone through. We have Q&A. We've got some time then to close off with any questions. I haven't seen anything come through on chat yet. So if you guys have any questions, please feel free to fire them off. If there are no questions, then I thank you for your time and your attendance. And as mentioned right at the beginning, this session was recorded, so we will be uploading this onto our YouTube channel for later viewing. If there's anything that you'd like to review from this webinar. haven't received any questions yet. I have also unmuted the participants, so if you do have a microphone and you want to ask a question, you're more than welcome. Okay, great. Seeing in the chat, no questions from one of the participants. And thank you for your attendance and have a great day as well. I think I will stop the presentation here then. This was, once again, it was a webinar brought to you by Micrographics. We do have offices in 4 locations in South Africa, so those details are up on screen. And once again, my name was Carl van Nooyen. Thank you for your attendance and your patience. And I hope that you have a great day further. Cheers.